Hello, today we're starting note set 8, which is looking at a geometric series. And so we have already figured out what a series it is. It is the sum of a sequence. So what does it mean to find a geometric series? So I've kind of gotten this written out already for us. So what this means is that we're going to take A1 and add it to A1 times R. Would that not be our second term? Then we're going to take our third term, and our third term is found by taking A1 and multiplying by R twice. And then we're going to add to that our fourth term, which is A sub 1 times R cubed. And so on and so on and so on and so on. Our last term is A1 times R to the n minus 1. Now, I kind of wrote the term before that for just a moment. A1 times R to the n minus 2. And so we're going to derive the equation to help us use the geometric series formula. And I would say out of all the different equations that we've learned, this one is less intuitive. It's not as intuitive as the arithmetic series where you guys figured out the pattern. It's not as intuitive as using just point slope form or using an exponential function. So that's why I'm doing this one with you. So this is more of a formal mathematical proof that you would see in upper level math textbooks. So first off, I'm just going to write down actually what I had above and what an arithmetic series would look like. So again, we're wanting to know how to quickly add these together. I mean, if this has 70 terms in it, we don't want to sit there and just add all of them together. We want to do this quickly. So my first strategy is actually going to be to take this statement and multiply that statement by negative R. Okay, now, in order to help you see that, I'm actually going to write a negative R out here. And then I'll write the result below. So negative R times S sub n would be negative R S sub n equals negative R times A1. I'm going to write that as negative A1R. A1 sub R times negative R would give us a negative A1R squared. A1R squared times negative R would give us a negative A1R cubed. Okay? And then so on and so on and so on. So let's do the last couple here. I'm going to have A sub 1 R to the n minus 2 times negative R. Now to help you with that, we know that would be a negative answer. And we know we'll have A sub 1 R to the n minus 2 and then times R. Now as a reminder, when you multiply like bases, you add your exponents. And so I'm going to keep the negative 1, negative A sub 1. This is really R to the first, and so I have like bases, I can add the exponent. So notice what I'm going to get there. I'm going to get R to the n minus 1 when I add those exponents. Okay, and let's do the last one. I'm going to have A1 R to the n minus 1 times negative R. And yes, that answer will be negative. I'll have A sub 1 R to the n minus 1 times R. Again, I'm multiplying like bases. I need to add my exponents. And so again, that's R to the first. When I add these exponents, I just get R to the n. Okay, so again, this is a formal proof. So I'm going to actually add these equations together. I'm deriving a formula here. So S sub n minus R S sub n. Not a whole lot I can do with that. Take just a minute and notice what happens if you were to start adding these together. Don't you have some like terms that will end up canceling out? A1R plus a negative A1R. A1R squared minus A sub 1R squared. a sub 1 r cubed and a negative a sub 1 r cubed. Negative a sub 1 r to the n minus 1. And actually the term immediately before that would have reduced or canceled out the a sub 1 r to the n minus 2. So let's see what we're left with. We're left with a sub 1 minus a sub 1 r to the n. Now, what is my goal? My goal is to find the sum, so I need to actually solve for s sub n. So in order to do that, I notice these two terms has s sub n in common, so I'm going to factor that out. If I pull s sub n out of s sub n, I'm left with 1, minus, if I pull s sub n out here, r. I'm almost there. I need to divide. So s sub n will equal a1 minus a1 r to the n all over 1 minus r. You've done it. You've solved for s sub n. You can now find the sum. I will say a lot of times this formula actually appears a little bit more simplified in that notice the numerator. Both of those quantities share an a sub 1. So a lot of times you'll see the a sub 1 factored out. So if you factor in a sub 1 out of a sub 1, you're left with 1 minus r to the n over 1 minus r. And there we go. So let's look at problem number 1. So problem number 1 says find the sum. So I'm trying to find the sum. I do not know n yet. I will have to find that. I do know a1. I know r. R looks like it's negative 2. So I just used my formula up here. In order to use this, I do need to come and to the side and find n. So I know that the first term is negative 6. I know that the nth term is negative 1,536. So I'm going to use the explicit formula. Negative 1,536 would equal negative 6. I do know r, it's negative 2 to the n minus 1. So first thing I'm going to do is I'm going to take negative 1,536 and divide it by negative 6. So one of my strategies here will be to try to write 256 as negative 2 to the something. I'm trying to make the bases be the same here. I'm trying to make the bases be the same. And so as I think about it, I know negative 2 to the 5th. I know that's negative 32. So it needs to be bigger than that. So negative 2 to the, let's try 7th, is negative 128. Ooh, I think we've almost got it. Negative 2 to the 8th would work. It is 256. Since the bases are the same, in order to make this be an equation where one side is equal to the other, the exponents would have to be equal. So I end up getting n is 9. I now can find the sum. I'm looking for the sum of the first 9 terms. I'm going to go ahead and write this denominator as 1 plus 2, so 3. And as I type this in my calculator, I'll kind of give you a heads up. I do not type this whole thing in at once. I'm going to do 1 minus negative 2 to the 9th. Then I'm going to take that and multiply it by negative 6. Then I'm going to take that and divide it by 3. Don't type it in one big step. It's really easy to miss your signs there. And so there's our answer. Okay, so let's look at example 4. I'm trying to find s sub 8. So this is geometric, hence why it says r. So I need to take a1 times 1 minus, I know r. Do I know n? Well, I do. It's actually 8 over 1 minus r. So I'll get 70. If you want to, you could type this in your calculator whenever. It's going to be a fraction, so I'm just going to leave it as it was and simplify a little bit. 1 minus 1/2 is 1/2. So again, when I'm using my calculator here, I typed in 1. Can you guys see that? I typed in 1 minus 1/2 to the 8th. I'm now going to multiply that by 70. Then I'm going to divide it by 1/2, or multiply by 2. I changed it to a fraction. I did math enter and changed it to a fraction, and so the sum is 8,925 over 64. Okay, we'll do example 6. So this time I know the sum. I don't know A1, that's what I'm trying to find. I know I'll have 1 minus, I know R, and I actually know N, look carefully, over 1 minus R. So negative 59,048 equals A1, 1 minus 3 to the 10th over negative 2. So I'm first going to multiply by negative 2. I'm going to go ahead and leave this because that's going to be an ugly number to try to write out. I'm now going to divide both sides by 1 minus 3 to the 10th. Make sure in your calculator you use parentheses there. And when I do, I find A1 is negative 2. All right, we'll do one more. Let's do 7. So as I look at 7, I know the sum. I know A1. I know R. I don't know N. So again, 1 minus negative 2 is the same as 1 plus 2, so that's 3. I'm going to go ahead and multiply by 3. I'm trying to get this exponential by itself, so I'm now going to divide by negative 8. And subtract 1. And divide by a negative. So we are actually trying to find N, and notice once again we have a problem like we did on the front. I need to try to write the bases the same. So if I take negative 2 and negative 2 to the N, I need to try to write 1024 as negative 2 to the something. And actually earlier I think that we found what 256 was. So 256 was negative 2 to the 10th, or excuse me, to the 8th. And so I'm thinking ahead there. And so we know it's bigger than 8. So you can take your calculator and figure out what that would be. And I've kind of already told you what it would be. 1024 is negative 2 to the 10th. So for these equations to be equivalent, the bases are the same, which means the exponents have to be the same. And so there N is 10.